All right, so this unit is just going to be completely on factoring. So what is even factoring? Well, you know how you multiply two binomials together and you get a trinomial? So let's say if you have x minus 3 times x plus 4. If you actually double distributive property this out, so you're just going to use the double distributive property, you're going to get x times x, which is x squared, x times 4, which is 4x, but then negative 3 times x is minus 3x, and then negative 3 times 4 is negative 12. So all of this simplifies out to be x squared plus x minus 12. Now factoring is when you go from a trinomial and you're going back to two binomials. So imagine if you weren't given any of this information and I just told you, okay, find out, a way to sort of go back to, what it originally was. So kind of the factored form for this, polynomial. And then that's when you use factoring. Okay. Now, factoring, what you do in factoring is basically you look for two numbers that multiply out to be the last term or the constant. So what two numbers multiply out to be negative 12 and add up to be the coefficient of the x term? So in this case, the coefficient of my x term is 1. So, once again, I'm trying to find out two numbers, let's just say two numbers that multiply out to be equal to the constant, and they add up to be equal to the coefficient of the x term, or just 1, right? Because 1 is the coefficient of the x term. And the correct combination, well, one way you can do this is actually, if I pull up my TI-84, okay. So one way to do it is actually you list out all the factors of negative 12. So the factors of negative 12 are, 3 and negative 4. You have 1 and negative 12. You have 12 and negative 1, and 2 and negative 6. And you can keep on doing this, 6 and negative 2, and so on. And you'll find out that the correct combination is actually negative 3 and 4. This is actually the correct combination if you actually just list out all the factors. Because think about it, two numbers that multiply out to be negative 12 are negative 3 and 4, and they add up to be equal to 1. Now, a good calculator trick is, in the Algebra 2 regions, they're going to be given a graphing calculator. So what you can do is you enter in your last term. So you enter in the last term. So in this case, it's negative 12. And you're going to divide it by x. And if you press second and table, it's going to give you all the factors of negative 12. So you notice 2 and negative 6, 3 and negative 4, 4 and negative 3, right? And then from this, you can see, okay, 4 and negative 3, they add up to be equal to 1. So that they have to be the factors of my thing. All right. So TI-84 is very useful. So you just take your constant term and you just divide it by x, and then they'll give you your factors. All right. So you can actually factor this out. You can actually factor this out to x minus 3 and then x plus 4, right? Notice how this minus 3, right? You have this minus 3, x minus 3, and I have this x plus 4. And I know that I have x minus 3 and x minus 4 because think about it, x times x gives me x squared. This is where the x squared comes from. So that's why, when we have, this factoring thing going on, I know that I have to have two x's here because they have to multiply out to be equal to x squared. We can do another example. Let's say if I have x squared plus 5x and then plus 6. So if we want to factor this, well, what are two numbers that multiply out to be equal to 6 and add up to be equal to the coefficient of our x term, which in this case is 5? Well, the correct combination, you can pause the video if you want to do these problems, but the correct combination is going to be, 3 and 2, right? 2 times 3 gives me 6. 2 plus 3 gives me 5. No, sorry if I wrote a 5 here. I meant a plus b. So it kind of looked like that was a 5. I don't know what that was. All right. So now what we're going to do is we're just going to place down, two parentheses like we did before. We're going to place x's in both of them because we know that x times x gives me x squared, right? I have to get this x squared term from somewhere, and it's going to be these two x's multiplied by each other. And now I'm going to put this x plus 3, which is corresponding with this part, and then x plus 2, which is corresponding with this part. And there's our answer. Now, you can actually think about why factoring works. Why does this strategy work? Well, when you have x, let's say you have x plus a times x plus b, right? When you factor this out, well, you use the distributive property, right? So it's going to be x squared plus bx, and then you can distribute this out, so it's going to be plus ax, and then plus ab. Now, these two terms right over here, I can factor out in x. Okay, now I know I'm kind of doing factoring when I'm talking about, factoring for trinomials, but basically, this is a different type of factoring. So it's actually, something known as basically GCF factoring. So imagine if you have 5 plus 10x. Both of these terms have a 5 in common, right? Because 10x can be 10x can be kind of seen as 5 times 2x, right? So both of these terms contain a 5. So what I can do is I can actually factor out in 5. I can rewrite this as 5 times 1 plus 2x. All right. When I do it this way, I'm basically doing the reverse distributive property. I see that both of these things have a 5 in common. So I take out a 5 from both of these terms. If I take out a 5 from 5, I'm just going to be left with 1. And if I take out a 5 from 10x, I'm going to just be left with 2x, right? Because if I take out a 5 here, I'm just going to be left with 2x. And you can confirm this by redistributing the 5 and noticing that, it yields the same result as the one shown here, 5 plus 10x. So in this case, what does bx and ax both have in common? Both of them have an x in common, right? So I can actually rewrite this as b plus a times x, right? Because both of them share x in common. And notice how if you redistribute the x, you get the same result as here. So all of this is equal to x squared plus b plus ax plus ab. And notice, right? We're looking for two numbers that multiply out to be the last term, a and b. And the two numbers have to add up to be the middle term, b plus a. So, this is where the factoring comes from. You can also do factoring for, higher terms. So if I have x to the 4th power plus, let's say, let me think of a good one. Let's say 2x to the 2nd power plus 1. How can I factor this? This might be a little bit tricky. Well, think about how you would factor x squared plus 2x plus 1. How would you factor this? You would look for two numbers multiplying out to be the last term, adding up to be the middle term. So what two numbers multiplies out to be 1 and adds up to be 2? Well, the correct combination is just a 1 and 1, right? Because 1 times 1 gives me 1. So, and 1 plus 1 gives me 2. So I can rewrite this as x plus 1 times x plus 1. Or I can write this as x plus 1 squared, okay? And this is actually something known as a perfect square trinomial, because, it's just this binomial squared by, it's multiplied by itself twice. So we're kind of going to use the same strategy here. Two numbers that multiply out to be 1 but add up to be 2 are just going to be 1 and 1, right? So I can actually factor this as x squared plus 1 times x squared plus 1. So instead of an x plus 1, I have an x squared plus 1. Because think about it, right? If I want an x to the 4th term, well, guess what? I'm going to have to multiply an x to the 2nd term and x to the 2nd term together, right? And I also have an x squared term, meaning that, I know that this won't factor out to be. So I know this won't factor out to be, let's say, x to the 3rd power plus 1 times x plus 1. I know that this isn't the way to factor this polynomial right over here. And the reason why is because if you actually FOIL everything, right, you're going to get x times this, which is x to the 4th power, but then you're going to have x to the 3rd power times 1, and that's going to lead you to an x to the 3rd power term. But the problem is that we don't have an x to the 3rd power term right over here. We only have an x to the 2nd power term, meaning that, we can't do this way, can't do it this way. And actually the correct combination is x to the 2nd power plus 1 times x to the 2nd power plus 1. Now, maybe an easy way to do this is you let y be equal to x squared. So instead of x squared being there, let y be equal to x squared. So if I actually rewrite the equation like this, I'm going to get x to the 4th power. You can rewrite this as x to the 2nd power to the 2nd power. So this is just going to be equal to y to the 2nd power. And then This is going to be plus 2 times x squared. Well, we know x squared is equal to y, so it's going to be y, and it's going to be plus 1. You can factor it out and into y plus 1 times y plus 1. And then after that, you can resubstitute x squared in for y, and then, you'll yield the same result. So, 16. How do we do this? How do we factor this? Well, once again, we're going to use this strategy. I like this strategy. We let y be equal to x squared. So we know x to the 4th power can be rewritten as x to the 2nd power to the 2nd power. So I can rewrite this thing as y to the 2nd power plus 10 times y plus 16, right? And now you know how to factor this, right? Two numbers that multiply out to be 16 and add up to be 10. Well, with enough practice, you'll instantly know that it's 8 and 2. 8 times 2 is 16, 8 plus 2 is 10. I can factor this out into y plus 8 times y plus 2. And now all we have to do is resubstitute x squared back in for y. So I'm going to get x squared plus 8. Wait, why did I write 8 2 times? So x squared plus 8 times x squared plus 2. And that's going to be our answer. So how can we factor this? Notice how you have, two perfect squares on the left and the right. So this can be rewritten as 2x to the 2nd power. This can be rewritten as 4y squared to the 2nd power. So this whole thing can actually be rewritten. One possible way it can be written is, the reason why I say one possible way is because doing this strategy doesn't guarantee that, you can actually, factor this, if that kind of makes sense. Like, you still have to check your work once you've actually factored this. But basically, you're going to get 2x plus 4y squared, and then you're going to have 2x. This is going to be multiplied by 2x plus 4y squared. All right, because 2x times 2x gives me 4x squared, and you have 4y squared times 4y squared, giving me 16y to the 4th, right? So, this strategy involves checking for two numbers that, or, two things that multiply out to be this first term, and then, just two things that multiply out to be the last term, and, both of them have to be like the perfect square version of it. Let's see if this works. So, always have to check your work, right? So 2x times 2x is 4x squared. This is going to be equal to 4y squared. 2x times 4y squared is 8xy squared. 4y squared times 2x is going to be 8xy squared. And then 4y squared, 4y squared, 16y to the 4th. This 8y squared plus 8xy squared is just going to be equal to 16xy squared. And, well, we are done. Now, let's say that instead of 4x squared plus 16xy and then that, let's say if I have 4x squared minus 16xy plus 16y to the 4th. How will the answers compare? Well, in this case right over here, it will actually be the same answer, except that instead of adding, you're going to be subtracting 4y squared. Now I want you to think about why that is. So when you have negative 4y squared times negative 4y squared, you're still going to get positive 16y to the 4th, right? However, when you actually start foiling out the 2x, you're going to get 4x to the 2nd power. 2x times negative 4y squared is going to be negative 8xy to the 2nd power. This times this is going to be negative 8xy to the 2nd power. And then finally, I said, you have positive 16y to the second power. And then all of negative 8xy squared minus 8xy squared is just minus 16xy squared. So notice, whenever you multiply x minus some number times, let's just say x minus some number, your first term is going to be positive, right? Your second term is going to be negative, and then your last term is going to be positive, okay? So this is kind of the same trend here. The only way that you can get a negative in the middle term and a positive in the last term is if both of the things are negative. If both of the things are negative, then we know negative makes it positive, and if you actually FOIL the rest of it out, well, you're going to get a negative middle term, right? If you have, let's say, x plus y times x plus y, So x plus something times x plus something, you're going to get x squared plus, let's just 2xy plus y squared. So it doesn't have to be the same number, but I'm just showing you this in this case, right? Notice how when it's x plus y times x plus y, all the terms are positive. X minus y times x minus y, the middle term is negative. And finally, the final scenario you got to know is if you have x plus y times x minus y, well, we kind of saw it in the, I did it in the imaginary units thing, but this is actually going to be, well, let's see. X times x is x squared. X times negative y is negative xy. Negative xy. Y times x is just positive yx or xy. Either way is fine. And then y times negative y is negative y squared. And so this all cancels out, right? Because negative xy and positive xy just cancels out, and you're just going to be left with x squared minus y squared. And this is something known as a difference of two squares. So if I have something like x squared minus 4, well, I know 4 can be rewritten as 2 squared. So I actually can factor this out into x plus 2 times x minus 2. If I have, let's say actually 4x squared minus 9, I know 4x squared is the same thing as 2x to the second power. I know minus 9 is the same thing as 3 to the second power. So I can rewrite this as, remember, x plus, so in this case, x plus, in this case I used y. Okay, so x plus y, and then it's going to be x minus y, right? Your x value is going to be, in this case, 2x. Your y value is going to be 3, right? So x plus y times x minus y. Equations, quadratic equations. So in this case, you can use the quadratic formula, but why am I making your life hard? So what I'm going to do is first, I notice that all of these terms have a 2. So all I'm going to do is I can either factor out a 2 from everything. So what do I mean by factoring out a 2? Well, I'm basically doing the reverse distributive property. So if I take out a 2 from 2x squared, I'm just going to be left with the x squared part, right? If I take a 2 out of 14x, I'm just going to be left with 7x. If I take a 2 out of 20, I'm just going to be left with 10, right? So you can think about it as 2x squared divided by 2 is just x squared. 2x squared divided by 2, 14x divided by 2 is 7x. 20 divided by 2 is 10, right? Because when you're doing the distributive property, remember that you have to multiply, right? So doing the reverse, you have to divide. And now you can factor the inside. So on the inside, what are two numbers that multiply out to be 10 and add up to be 7? And the correct combo is x plus 5 times x plus 2 is equal to 0. And don't forget the 2 on the outside. So using the zero product property, so the zero product property basically states that if you have actually let me just do x times y is equal to 0, either x is equal to 0 or y is equal to 0. So for example, if you have, let's say, I don't know, x plus 1 times y plus 1 is equal to 0, either this part of the equation is equal to 0, so either x plus 1 is equal to 0, or y plus 1 is equal to 0. So, if you subtract 1 from both sides, you either get that x is equal to -1 or y is equal to -1. And that kind of makes sense, right? Because if you plug in y is equal to -1, you get -1 plus 1, which is 0, and 0 times whatever this is 0. And if you plug in x is equal to -1, well, you get the same result. -1 plus 1 is 0. 0 times whatever this is also going to be 0. So, the zero product property takes advantage of the fact that if you're multiplying two things out together, if one thing is equal to 0, then the other thing is basically non-existent, because 0 times whatever that thing is 0. So, you're going to get the same result. So in this case, I can say that either x plus 5 is equal to 0, or either this thing is equal to 0, or x plus 2 is equal to 0. So either x is equal to -5 or x is equal to -2, and that's going to be our answer. Now let's say if we're trying to solve this equation, how do we do this? Using factoring, okay? So that's the thing. I don't want y'all to use the quadratic formula for this. I want you to do this by factoring. And there's a method called factoring by grouping. Basically, what you do is you take the coefficient of the x squared term and you multiply it by the constant. So 8 times -5 is -40. Now what you're going to do is this is going to be a very similar process as you've seen before. you're going to find two numbers that multiply out to be 40 and add up to be negative 18. Okay, so two numbers that multiply out to be the first and sort of last term multiplied together, and then they have to add up to be the middle term. What is the correct combination? Well, the correct combination is 20 and 2, and positive 2, right? They multiply out to be 40, add up to be negative 18. So what we're going to do is we're going to break the middle term up into negative 20 and 2. So what's going to happen is we're going to have ax squared. We're going to have ax squared minus 20x plus 2x minus 5 is equal to 0. Notice how negative 20x plus 2x still adds up to be negative 18x. So we actually haven't changed the value of this equation. We just altered it in some way. Okay, so this first thing we did over here just tells us how do we break down this middle term. Now, we can factor by grouping. All right, so this method is called factoring by grouping. We're going to group the ax squared and this 20x together, and this 2x minus 5 together. We can factor out, what can we factor out from ax squared and negative 20x? Well, we can factor out a 4x, right? 4x times 2x gives me ax squared, and 4x minus 5 gives me 20x, right? 4x times negative 5 gives me negative 20x. Now, I can factor out a 1 from this term, so it's going to be 1 times 2x minus 5 equals 0. Notice how I have a 2x in both these terms. So what I can do is I can factor out a 2x from everything. So basically, imagine if I have a 2x minus 5. I took out 2x minus 5 from each of these terms. What am I going to be left with? I'm just going to be left with 4x plus 1. And it's going to be equal to 0. All right, so when you're factoring by grouping, the things on the parentheses sort of merge into one thing, and then the things on the outside merge into their own thing. Okay? Because both of these terms have a 2x minus 5 in common. So imagine if you factor out a 2x minus 5, you would just be left with 4x plus 1 is equal to 0. Now we can solve for 0, so either 2x minus 5 is equal to 0, or 4x plus 1 is equal to 0. So either x is equal to 5 over 2, or x is equal to negative 1 over 4. Now, actually, in the regions, you're going to be gifted a graphing calculator. So what you can actually do is, okay, so ax squared minus 18x minus 5. So I'm going to have ax to the second power minus 18x, sorry. Minus 18x, and then this is going to be minus 5. Okay, so you're going to graph this out, and you're going to see it has two solutions. Now, you're going to go to second, trace, and you're going to go to 0. So if you want to find a left-bound solution, what you do is you want to select a point upwards, and then select a point downwards. It's going to give you the answer. First 0 is at negative 0.25, which is what we got here, negative 1/4. Now, if you want to find a solution, the 0 on the right, what you do is, once again, you do the 0, but this time you're going to select a point downwards, and then you're going to select a point upwards. And then this is going to give you the 0. So when you're on this side, you're trying to find 0, this 0, select a point up, and then a point down. When you're on this 0, select a point down, and then select a point up. Now, finally, we have this problem. And I really like this problem because it's kind of like an all-in-one lesson. So first of all, in order to factor this, what I'm going to do first is I'm actually going to factor out a 3 from each of these terms. Because I noticed that all 3, 15, negative 12, and negative 60 are all factors of 3. So when I factor out a 3, I'm going to be left with this. X squared. If I take out a 3 from negative 12x, I'm just going to be left with 4x. I'm just going to be left with 20 there. Now notice that I can actually group these terms up. So now I'm going to be factoring by grouping. So what I'm going to do is, this is factoring by grouping for, things that are in higher for power. So what we do is we kind of group these terms up into two sections. And now I can factor out an x squared from x to the third power and 5x to the second power. So I can group this into x squared. So I can factor this into 3 times x squared. And then this is going to be x plus 5, right? Because
If I take out an x squared from both these terms, well, if I take an x squared out from x to the third power, I'm just going to be left with an x. If I take an x squared out of 5x squared, I'm just going to be left with 5. And for this part right over here, I can factor out, so I can factor out a 4 from both these terms, or -4. So I'm going to be left with x here, I'm going to be left with positive 5 here. Notice how, actually let me put a parentheses to make this clear, but notice how these two things on the inside are the same, meaning that I can actually factor by grouping. Okay, so in this case, remember, these two things sort of merge into one term, right? So these x plus 5s merge into one term. And then this things that aren't in parentheses are going to merge into another term. And don't forget, we still have this 3 on the outside. Now, x squared minus 4 is a difference of 2 squares. So I can rewrite this as x plus 2 times x minus 2. Don't forget the x plus 5 and then the 3. But then we are done. Can't really factor this any further. So, be careful. One mistake I almost made it is that I almost put a 3x to the second power on the inside, because I saw that I had this 3 and I have this x squared, and these are things remaining, so I should have a 3x squared on the inside. But that's not actually the case, because remember, right, this 3 is on the outside of this parentheses, so it's not actually going to be kind of involved in all of these calculations. Okay, so when I'm factoring by grouping for all of these terms, this 3 is still going to be on the outside. It's not involved in the grouping process.